Greetings everyone. The title of the presentation is Residual Strength Estimation of Damaged Steel Tubular Columns using 3D Digital Image Correlation. I am Prithvi Sangani, a PhD scholar from IIT Hyderabad. Steel tubular columns are extensively used in modern construction due to their high structural efficiency, resistance against torsion and buckling, aesthetic appearance, etc. Due to accidental damage or unintended loading conditions, the load carrying capacities of these sections is reduced. It is easier to predict the capacity of perfect geometry or shapes when compared to the damaged or the deformed shapes of the specimen. Therefore, the objectives of the study are to impart initial damage by axial compression to factory-made specimen, model the damaged shape, and perform finite element analysis to estimate the residual capacity. For this, two specimens, one circular C1 with 165 mm dia and square S1 with 220 mm side is studied. Coming to the methodology, initially by axial compression, damage is imparted to the factory-made specimen, then the damaged specimen is scanned using 3D digital image correlation setup, stitched and nodes are regularized, then the edges are smoothened by two-dimensional Fourier transforms, meshed, imported to the abacus, which is an finite element analysis software, and analyzed to estimate the residual capacity. The same is compared by performing the experiment on the damaged specimen. Coming to the experimental setup, compression testing machine of 5000 kilonewtons capacity is used. We can see the images of undamaged and the damaged square specimen on the right side of the experimental setup. The stitching procedure which is proposed in the methodology is validated by performing the stitching on undamaged circular tube, and the diameters are compared and observed to be the same. Coming to the results, the finite element results match accurately with the experimental results for the axial capacity of the undamaged tubes. But the post-peak variation can be improved by measuring geometric imperfections, residual stresses, and incorporating them into the finite element analysis. The error, the error for the residual strength estimation for the circular tubes is about 6%, and that for the square tube is about 11%. Therefore, the proposed method predicts the residual strength with reasonable accuracy. The finite element failure modes are well captured and match the experimental failure modes that can be seen in the picture. Thank you.